All right, in Learning Target 12 and in 13, 13 is going to go into one dimension, two dimension as well, but it's going to have three dimension in it as well. We're going to be working with three variables, three equations. So we move into a different graph and a different setting. Here's an example of a problem. And I promise you on your quiz and test, you will have one of these for sure. One of those that has all three variables and all three equations. Some of them won't have all three, and we'll kind of see what happens there, but you're going to have at least one of these. All right, now each equation represents a plane. So if you remember from geometry, it's kind of like three pieces of paper. And the book does the better than I could ever do, of showing you what it looks like when three pieces of paper intersect at one point. Okay? It's called an ordered triple, kind of like an ordered pair in two dimension. Now there's same options as there were in two dimension. One answer, an ordered triple, infinitely many answers, or no solution. So this three dimension thing, all right, the video, this isn't going to help any, but we're doing this in class, so we'll go ahead and I'm going to stand right here in the room in three dimension. Where's my nose? On my face, okay. My nose, to get to my nose, I'd have to have three reference points. All right, so here's how it works. To visualize three dimension, look at this corner of the room. Where the wall meets the floor is the x-axis. Where the wall meets the floor over here, y-axis. And the seam that's going where the two walls meet, that's the z-axis. Okay? So if I'm standing right here, I'm about 5 feet up the x-axis. I'm about probably 8 feet over here. And then my nose is about 5 feet up. So my ordered triple would be 5, 8, 5. Does that make sense? You need 3 points anyways. All right, so the other ones, the infinitely many solutions and the no solution, we'll kind of look at these as they come up and just talk about them. Okay, but they're definitely the weird ones. And then I wanted to show you, this isn't in your notes, but this is how on paper you would have to graph an ordered triple. We're not going to on paper. We're only going to be solving them algebraically. We won't be graphing. But to graph 3, 5, 8, I'd count over 3 on the x-axis. I'd count over 5 on the y-axis. So 1, 2, 3, 4, 5. And then I'd go up 8. So up 8 would be approximately right here. It's hard to draw a three-dimensional something on a piece of paper, which is two-dimensional, but that's kind of how it works. You got to train your eye to see it. But that's 3 dimensions on a two-dimensional surface. It's kind of hard to see. Anyways, that was all side notes. Now let's dig in. The big picture today. The big picture today. You don't have this on your notes. But the big picture is this. Try to take the problem that you're given and somehow turn it into a Learning Target 8, where there's only 2 variables and 2 equations, because you know what to do with those. If you can get it down to where there's only 2 variables and 2 equations, you can substitute, eliminate, you can do whatever you like from there. All right, so usually this requires making 2 groups of equations so that you're using all 3 equations that were in the original problem, and you eliminate the same variable. Sometimes one of the three equations only has two variables to begin with, so you can kind of use that to your advantage. And then last, sometimes you just have to be creative. Sometimes it's just kind of obvious what you should do. In the first problem we're going to do, it's going to be kind of obvious what we can do to find x, y, and z. All right, so here we go. First problem. And there are directions here, and the most important direction is to slow down when you see the problem and think about, what am I going to do? Make a plan. It's kind of like chess. You need to see a few moves ahead before you make the first move. You got to make a plan. All right, so I'm looking at problem number 1. 2y plus 3z equals 19, and x equals 1, and a 3x plus 5z equals 18. And that's a gift, that middle equation, x equals 1. That's x. Can you use that somehow to find one of the other variables? Yeah, you could plug it into the third equation and get z. And then once you had z, you could go up to the top equation and find y. So that's the plan that I typed up right here that we would use here. X is 1. And then we'll use that x value 1 in the third equation. So 3 times 1 plus 5z equals 18. We'll subtract our 3, and 5z equals 15. Divide by 5. Z is 3. The ordered triples in alphabetical order, so x, y, z, that goes there. And the last one, the plan said once I've got z, I'll take it and put it into the first equation. So 2y plus 3 times z equals 19, and we just found out z was 3. So we'll subtract 9. 2y equals 10, so y is 5. Our ordered triple is 153. Here in the room, that would be off the wall here, 5 feet over, and then 3 feet up. Just for kind of reference sake of where is that point in space. All right, number 2. Notice that the first equation doesn't have an x, but the other two, they do have an x, right? All right, so because of that first equation looking like it does, I'm thinking learning target 8. I'm thinking, how can I make this look like learning target 8? Well, what we can do is take the second and third equation and get rid of the x. If we take the second and third equation and get rid of x, what's going to be left? A y and a z that we can use with our original first equation and create a learning target 8, a 2-variable, 2 equation. So that's the plan that's kind of written up here. Because of the way this problem's set up, it's going to be best if we get rid of x, eliminate x, in the second and third equation, and then pair our answer with the original. So what are we going to do to eliminate x? We'll have to multiply the third equation times 2. So when we do, I'll just copy the original second equation down. I'm going to double everything in the third equation. So negative 4x minus 2y minus 2z equals negative 6. And then add them to eliminate x. Wait a minute. What's happening? X eliminated, but so is y. So all we've got left here is z equals 1. So we had a plan. We planned on eliminating x and then going and doing a learning target 8. But now we've got z equals 1. New plan. The new plan, now that you've got z as 1, what can you do with it? Take it and put it into the first equation and find y. Take the 3y minus 5z equals negative 23, and plug that z value 1 right there in, and then you can solve for y. So that's a negative 5, so we'll add 5. 3y equals, when we add 5, we get negative 18. Divide by 3, get negative 6. So we've got 2 of our answers so far. Z is 1, y is negative 6. All right, how are we going to find the last one? It doesn't matter which equation you pick, the second one or the third one. But one of those two, take your y value negative 6 and your z value 1 and plug them both in and find the x. I like the first one, the 4x plus 2y plus 3z, because it's all positives, and I like dealing with positive numbers, so it's just a preference thing. But 4 times x plus 2 times y plus 3 times z equals 7. And then we'll plug in our z value 1 and our y value negative 6. So we get 4x minus 12 plus 3 equals 7. Combine like terms, you get negative 9. You add 9 to both sides. Divide by 4, and x is 4. So 4, negative 6, 1. 4, negative 6, 1. Where's that in space? All right, here's our origin. 0, 0, 0. 4 to the right, so 4 this way. Where would negative 6 be? It'd be in the hallway, and then up 1. All right, just for reference, just so you can kind of see where's this answer, what is it, okay? All right. Now we finally get to, no, we still don't. It's number 4 where we finally get a 3-variable, 3 equations. But I want you to try this one, try not to read the plan that I've made. But think about what you've got and what you might could to turn it into a learning target 8. All right, I'll pause the video. You guys think, but again, try not to read what I've already typed because the answer's right there. and think about what would you do. Okay, so we paused just for a minute and talked about it. The third equation doesn't have a z, so we're going to take the first two equations and get rid of z. And they're kind of just begging for you to eliminate z as they're sitting. It's a positive 2z and a negative 2z. So we'll add these two equations and get another equation that has x and y in it, and then we'll have our learning target 8. Two equations with x and y. Let's see, x plus 6y minus 2z equals negative 2. We'll add these up, eliminating z, and get 4x plus 4y equals negative 4. We will now take the equation we just got and pair it with the third equation that also has an x and a y, and have two variables, two equations, learning target 8. If you like substitution, go for it. If you like elimination, you do it however you want, but what are you ultimately going to find? A number for x and a number for y, and once you have those, you can go back to the original and find the z. Okay? So the first goal of all these problems is somehow figure out a way to turn it into two variables, two equations, and then you can finish it from there. So, all right, these two together, I like elimination. I'm just a fan of elimination. So I'm going to eliminate the y's. So I'm going to multiply this one times negative 2 to make a negative 4y. All right, so when I multiply by negative 2, I get negative 2x minus 4y equals 0. Bring this equation over. 4x plus 4y equals negative 4, and then add them. We get the y's to cancel. We get 2x equals negative 4 divided by 2, and x is negative 2. So our answer so far, negative 2. Then I'll take the original x plus 2y equals 0 and plug in x and solve for the y. Add 2 to both sides, divide by 2, y is 1. All right, and then that was nothing more than a learning target 8. But now that we have those two numbers, we can either take the first original equation or the second one, either one, and put the x value negative 2 and the y value 1 back into it and solve for the remaining z. All right, so I'm going to pick the first equation, 3 times x minus 2 times y plus 2z equals negative 2, and replace x with negative 2 and y with 1. So we get negative 6 minus 2 plus 2z equals negative 2. Combine your like terms, negative 8. Add that 8 to the right side, divide by 2, and z is 3. So final answer, the ordered triple, negative 2, 1, and 3. Negative 2, 1, and 3. So where would that be in space? Over here in the corner of the room, negative 2. So instead of coming out 2 this way, we'd go into Mr. Jackson's room, right? Negative 2. Then we would go towards his desk 1 foot, and then up 3. All right. Well, the last problem, number 4, has all 3 equations, 3 variables, and there's so many ways to do these problems. I mean, I'm just giving you one option, okay? On this next page, I've actually given you 4 options. The one that we're going to do at the top, but then 3 more options at the bottom that you could do. But before you read them, I want you to think about what you have, 3 variables, 3 equations, and how are you going to make it turn into a learning target 8? Only 2 variables and 2 equations left. This is that example where you have to take 2 equations, put them together and make a group, and make another group with 2 equations and eliminate the same variable. So the first thing that I would look at a problem like this, look at all the variables and which one, is it x, is it y, or is it z that's going to be the easiest on you to maybe get rid of? Which variable is like tempting you to eliminate it? Yes, the y, because you got a positive y and two negative y's. So I personally would choose to group the first two equations, get rid of y, and then group the second two equations and also get rid of y. Again, we're making a plan, so don't start acting on your plan until you know exactly what you're doing. What's going to happen if we do that? If we eliminate y in the first group, we get an equation that has x and z in it. What's going to happen if we eliminate y in the second group? We get another equation with x and z in it. And then we put those two together and finish it learning target 8, right? Okay. Because sometimes when you start a problem, you think it's easy to eliminate x here, but it's easy to eliminate y over here, and then you get to a point and we are going to come to me and say, well, now what do I do? Because I can't, and if your plan wasn't thought through, you can't do anything. You just have to go back and start over, okay? So anyways, let's do that plan, put them together. The two groups, the first group, 2x minus y plus 2z equals 15. Negative x plus y plus z equals 3. And then negative x plus y plus z equals 3, paired with 3x minus y plus 2z equals 18. Add these because the y is ready to eliminate. And we'll add these because the y is also ready to eliminate over here. All right, first, the blue, we get x plus 3z equals 18. And in red, we get 2x plus 3z equals 21. So far, plan's coming together. We got an x and a z and another x and a z. Now we can put those two together as a learning target 8. I like elimination. You could be using substitution right here. You could use substitution even in the first step. You can solve these so many different ways. This is just one option, okay? With elimination, though, I see a 3z and a 3z. I'm just going to turn one of them into negative 3z. So I'll multiply this second equation times negative 1. It doesn't matter which one. And then put the blue with the new red equation times negative 1 everywhere. So negative 2x, negative 3z, negative 21. And add them, and we get the z's cancel. We get negative x equals negative 3. So x is 3. A lot of work to get x is 3. All right? But we're still in learning target 8 mode. We had an x and a z equation. Go get the z. You've got an x and a z. I like the blue one. X plus 3z equals 18. And plug in x right there. So 3 plus 3z equals 18. Subtract the 3. Divide by 3. And z is 5. So we got two of our answers. X is 3, z is 5. All right, how are we going to get the last one? We had a plan. Take those two numbers and plug them back into any of the original equations. Any of them. Take your favorite. Does not matter. I like the one that already has a positive y, plus it also illustrates something else. Negative x plus y plus z equals 3. If that says in the equation negative x, then you need to change our 3 that we're going to plug into it to negative 3. The opposite of x, so negative 3 plus y plus the z that we found was 5 equals 3. Combine like terms, y plus 2 equals 3. Subtract your 2, and y equals 1. 3, 1, 5. All right, now I'm just going to mention some of the other options you had at the bottom that are typed up for you. But you could have done this. Take the two original equations, the first two that I've got circled there in blue, and eliminate x. And then take the two that are circled. Is that green or red? Red. Okay, I was making sure. I wasn't sure if I clicked on the red up here. But this one's red? Okay. The two that are circled in red, you could also get rid of x And what would happen in your blue and your red this time? No x's, so you'd have y's and z's. Okay. Whichever, here's the important part, because I know you guys are following me, and you're feeling okay about this, right? When you get to a test or a quiz, sometimes it'll just say find x. And this is important. If you choose to eliminate x in the very first step, it's going to be the last one that you find. What did we eliminate in this problem? We eliminated y. Agree? What was the letter we found, or when did we find the y value? We found it last. All right? The end of course likes to do that. It likes to say, here's the problem. What's the value of x? So don't eliminate x first. If you're on a time crunch, eliminate y or z, and then you'll get x sooner. Anyways, that's a little bit advanced. Last thing, what did we not see an example of? No solution or infinitely many. So we're going to have to talk about that when it comes up in the homework, okay? I've got a very minimal assignment for homework. Let me stop the video.